Hello everyone, Prairie here. Welcome to today's presentation. So guys, in today's presentation, we're going to talk about CI/CD. It's one of the hottest things everybody's talking about today. But how different are they? What is CI and how exactly is it different from CD? Or more importantly, what is CD in CI/CD? So we're going to be looking at that in today's presentation. That said, we're going to start from the very first one, which is the CI piece. And CI, that simply stands for continuous integration. Continuous integration. So the CI of CI/CD stands for continuous integration. But what exactly does the continuous integration mean? So let's use an example of a developer. Let's say you're working on a team, you as a single developer or a team of multiple developers. And what you do is you write some code. All right, this code could be Java, it could be Python, C++, C#, whatever code you write that code. Now, normally you can write a code in Notepad or any one of your favorite IDEs, right? So JetBrains, NetBeans, Eclipse, PyCharm, you name it. There are lots and lots of them. Visual Studio Code. But basically you write your code in your favorite language. Now, the CI, the continuous integration, where that comes into play is with this whole idea of source control. All right, because if you write your code and you keep it on your desktop, it's not going to be very valuable to a lot of people. So CI says, all right, if you write your code, all right, what you want to do is to check that code into some form of a source control. All right, SC, and this could be Git, it could be SVN, and more. But Git is really the de facto. So usually a lot of people today are going to be using Git or GitHub or Bitbucket. There are lots of them, but it's under the Git flavor. So you write your code and you check it into Git. So that code, you commit the code, you check it in, and it goes into your Git repository. So what you're doing is you're integrating that code into the Git repository. So this is a CIP, so continuous integration. As you're writing that code, you're integrating that code into Git. All right. Now you can organize Git in different ways, right? People might have a dev branch, a test branch, a master branch. I'm not going to go into the details of how to structure Git, but just think about it as you write that code as a developer, it sits on your laptop, and the moment you commit and you're pushing that code up into Git, that is your integration. All right, and you want to do that throughout the day, every hour or so. As you're writing code, you're making changes, you're integrating that into Git. That is your integration piece. Now, the next piece that usually comes in handy for the CD piece, and this is where it gets a little bit confusing, but we're going to talk about it today, is a CD. All right, and CD simply stands for continuous deployment. All right, so the CD in CI stands for continuous deployment. And what does that mean? What exactly does that mean, right? As a developer, you might think, oh, I just wrote my code and I committed it into Git. Isn't that deploying the code? All right, not so fast. All right, so I'm going to talk about where this continuous deployment comes into play. But to do that, we have to understand what exactly you're doing here. So if you're writing a code and you have your source code and you're committing that into your repository, what you're doing is basically you're committing source code. So if you take something like Java as an example, all right, when you write code, you're actually writing just Java. You are writing .java classes, so your code will be in .java files. All right, so it's just .java. But these Java files, that's just code. You can see it. You can see all the code you've written, but you can now run this. What you need to run is you need to somehow compile that into .class and then even package it up into .jar. So this jar is a runnable. You might hear of the term runnable. All right, this is what, if you want to run your nice program, you need it to be in this state of .jar for you to run. All right, so even though we saw here you write your code, you commit it into source control, you're just integrating that code. All right, but a bunch of other things still needs to happen for that code to actually run. All right, And this bunch of other things is what will fall under the CD, the continuous deployment part. So the way it usually works is you write your code, you commit it to Git. Let me actually put a boundary here. All right, so we see this section. So the continuous integration is the developer writing their code, committing that into Git. You're checking that into Git, all fine and good. Now, the CD piece is, let's say, and I'm using Java here as an example, but it's going to be true for many languages. You have your code is .java, right? That's the file where you write your code. We need to take that, compile that to .class. Then, depending on the code and all the dependencies that we need to build that into a .jar, all right, or .war, depending on what kind of application you're building. And at this point, we are bringing in all the dependencies that we need. If there are dependencies, libraries, other artifacts that we need. All right, we want to bring all of that and bring it into building this thing here, which is going to be your runnable. All right, and this is what actually runs. So now you might be asking, well, all I just did was write my code and commit to Git. Who is gonna do this piece of building, compiling, and taking care of all the dependencies to make this code actually runnable? Who is gonna do that? All right, that is where the continuous deployment comes into play, and it actually takes the help of certain tools, right? So this is where you might hear of something like Jenkins. Jenkins is an I. All right, so what Jenkins would do is, so we have Git is the repository for the code. So what Jenkins can do is it can listen, right? Jenkins can listen to Git, all right, and you can set this all up. The details of how you set it up might change from one organization to the next, but what you do is you actually set up a hook on Jenkins to listen to a Git branch. And the way it works is you say, all right, when a commit happens into a Git repository, Jenkins is going to listen to that, and depending on how you've set up your CI/CD flow, once Jenkins sees a commit to this Git branch, it's going to take that commit and it's going to do all these builds, and now it has something that it can actually run, and then this runnable gets pushed into your environment, and this could be prod. And I'm just oversimplifying this here. All right, so you're writing your code and you're still in dev here as an example, and as soon as you push it to a branch in Git, Jenkins listens to that, all right, and it takes care of doing the build. So this is what they talk about, a build. So Jenkins does your build, runs your build scripts, and it builds that. In the case of Java, is .java to .class, right? Because you have to compile it in a way that the JVM can understand, and then it creates the jar files, which is basically your runnable. This is something that is the application that can actually run. Code is not an application, right? This is something that can actually run, this runnable, and then it deploys it to your prod environment, which could be a server somewhere. All right, this could be your web app somewhere, and so Jenkins will push this new code. So if you add a new button to that code, Jenkins is going to listen, do the build, and then push it to the server, and your new button is going to show up in your prod server, and this is continuous deployment. Now, one of the key things when talking about continuous deployment, and I used to talk about this quite a bit, is you cannot have true continuous deployment, or at least, I mean, people can do things in different ways, but I'm of the philosophy that you cannot really have true continuous deployment without tests, without test cases, all right, without some form of testing, because otherwise, who knows that if you made a change here and introduce some defect into this code, what stops Jenkins from just taking that defect and building it and just pushing it to production and causing more problems? All right, and so what happens is when you write your code, ideally, if you're following the right processes, you want to include your test cases. You want to make sure that your code includes, let me put in here, you're also giving that code unit test. All right, You're also giving some form of unit test to that code. So now once you commit all of that and your Jenkins listens to that branch, it pulls the code before it does the builds and puts it to production. It runs through a battery of test cases first. Now if there is a failure in any of those test cases, well, you don't want to be deploying to production. So if there is a failure, so if your test cases fail, right, you maybe want to notify somebody, provide a report, and not push it to production. You might want to push it to some other environment, again, depending on how you set this up. So if your test cases fail, you don't want to push it to production. Now, if your test cases that you've included as part of your writing of your code, because the developers have to write their code with the test cases, this runs all the automated test cases, and if that's successful, then you can push it to production. So you have the confidence that your team is only going to promote to production things that work and don't break that code. So sometimes when you hear about teams talking about, oh, we deploy the production 200 times a day. I was listening to some video where some guy was talking about in the startup they were working on, they were pushing things to production 200 times a day. And you're asking, how is that possible? No, how doesn't that break things? The reason why that is possible is if you have good test cases. And it does take time to set up this pipeline. But when you set it up, it works. It works like a charm. All right, your developers can just write their code, check it in. Usually you have to set up Git in more sophisticated ways where you have a dev branch. All right, the developers might check it into dev branch, have somebody review that before they push it to a master, and then that kicks over the CD pipeline, which is usually in Jenkins, right? And then Jenkins does the build. It runs through the test cases. If the test cases are successful, it pushes to production. If there's a failure in the test cases, it rejects that build, or it sends an error message to somebody per the workflow that has been set up, and then that process can repeat all over again. But this is what CI/CD looks like in the world. I know this might be confusing for some people. What exactly does the CI means? What does the CD means? And where do they demarcate? This is really how it separates. CI is basically the continuous integration. And when we talk about CI, we're really talking about Git. We're really talking about some form of source control. All right, it could be a GitHub, it could be a Bitbucket, it could be Azure repo, it could be, I know AWS has some repository over there. It could be any repository that you use for just managing your source code. Now, when we talk about CD, which is a continuous deployment, all right, this is really that process of taking source code from Git using some form of build tool, which one of the common ones is Jenkins, and then Jenkins does a build. It pulls in dependencies, and usually, and I'm gonna just make this a little bit confusing for you guys, usually these dependencies or these artifacts that it needs might be coming in from some artifact repository. All right, Nexus is a popular one. All right, so Nexus is a popular artifact repository, so you might use Nexus, Artifactory, JFrog, or there are many of them out there. JFrog, Artifactory, right, to pull your dependencies, and it builds a runnable, and that's the runnable that can actually execute as an application. But if your test cases fail, well, you want to maybe notify somebody and then repeat the cycle all over. So when you think about CI/CD, I believe this is how people would always draw something like this. All right, and this is kind of infinity from my days doing math, where somewhere here you'll be gathering requirements, specifications, something like that, and then here would be code, test, deploy, all right, and then monitor. But you can just kind of put in whatever steps you want in here, but the whole idea is you start somewhere, you gather your requirements, you code, you test, you deploy, you monitor, you get new specifications, you develop requirements, and you kind of just repeat this all over and over again. All right, and people have taken this to the nth degree, right? There is a CI, which is continuous integration. There is a CD, which is continuous deployment. There is another CD, which could be continuous, continuous delivery. There is CT, which could be continuous testing. You know, anybody can put anything in there with the continuous in front of them, but this is really the essence of CI versus CD. Hopefully this was helpful, guys. I hope this was helpful. If you have any questions around this breakdown, don't hesitate to let me know. This is a very powerful concept. You know, almost everybody today is talking about DevOps, and CI/CD is a key part of DevOps. And if you really want to get agility and speed when building products, whether you're talking about applications or data products, this is something that you have to pay attention to and master. And I hope that this gives us a brief understanding of what CI versus CD all stands for. All right, thanks for watching. Thanks for joining me. Please subscribe if you haven't. Share this with somebody that might get value out of it. We make presentations and lectures like this. If you have any feedback, jump into the comment section below. Let me know. Thanks again. This is Fro. I will see you in the next presentation.